Up until now, we've been talking about training networks, and the networks are going to get larger. We're going to train it with more capability. We're training it so that it can predict more things. It can infer more things. But one of the most important areas of deep learning is ultimately to deploy, to apply that network on production services, to actually use the network we've trained. This is an area that we've been thinking about for quite some time. Unless you have high-quality networks, the reason to deploy it is obviously not there. But because of all of the work that researchers like Andrew has been doing around the world, we now have so many different types of networks. We have so many companies that have been formed. We have so many industries that have now tried deep learning. It is now time for us to create computers that allows us to take deep learning to billions of people. Ladies and gentlemen, today we're announcing the Tesla P4 and P40. The Tesla P4 and P40 comes in two models. One of them is a GPU that looks like an NVIDIA GPU, very powerful. It goes into a high-performance server. You can put multiple GPUs in a single server. And as Andrew said earlier, data centers are recognizing the importance of using GPUs for inference production. And so as a result, data centers as well as servers are being redesigned to accommodate GPUs like the Tesla P40, the world's first GPU designed for inferencing, based on a brand new architecture called Pascal, has a new instruction set optimized for deep learning, and a new numerical format, integer 8 bits. This is 250 watts and 40 times the performance of a CPU. 40 times the performance of a CPU. And so what this basically says is by putting one Tesla P40, you can replace 40 CPUs. But if you could put 8 Tesla P40s in a single server, you can remove and replace racks and racks of CPU servers. However, there are servers that were designed using the OCP 1U hyperscale standard, and the amount of power delivery capability is limited. And so we designed a second, a cute little, super cute, super energy efficient Pascal inference accelerator. You plug this right into a 1U server, and you accelerate that server with the Pascal GPU. These two represents the new Pascal inference accelerators, designed for hyperscale data centers, designed for production, deployment of neural networks that are trained on NVIDIA GPUs. Okay? The Tesla P4 and P40. The networks that are being created are really, really complex. As we've been saying, the parameters, the model size is increasing incredibly fast. In just 650,000 neurons, or a few 60 million parameters, it has grown by factors of 10. Factors of 10s at a time every year or two. And that trend is going to continue. And so we need faster and faster processors. But we also want to make sure that the networks that we're deploying into the data center is fully optimized. And so we create today, we're announcing a brand new technology. It's a software technology. It's an optimizing engine technology. It's called TensorRT. A brand new product. It's a software product that runs on top of our GPUs, TensorRT. It takes basically the network that was trained, runs into optimizing engine, It fuses layers horizontally and vertically. It does auto-tuning. It retargets the network from FP32 to FP16 to N8 wherever it can, reducing the precision that's necessary, and as a result, increasing the throughput, increasing the bandwidth, and reducing the storage necessary. And it does that all automatically. We support all of the major inferencing networks today, BGG and GoogleNet and ResNet and AlexNet, and it also allows you to customize your own layers. TensorRT. It reduces the complexity by sometimes 2x, 3x without affecting the accuracy of the network. It is something you absolutely must do before you deploy this network into your data center. You just get a magic speed up on top of the incredibly fast GPUs you already have. Just that magic speed up. It's really, really fantastic. Ladies and gentlemen, TensorRT. Go to NVIDIA's website to download it right away. So let me demonstrate it to you now. Okay, what you're going to see, the demonstration you're about to see, we have 90 live videos that are going to be streaming through a server. These 90 videos, several things has to happen. You have to ingest 90 videos. 90 videos. You have to decode it, do image processing on the decoded images, and run it through inferencing